called a diamond puzzle, and it's something you might not have seen before, but if you can get your brain kind of wrapped around a diamond puzzle, it's looking for factors of a number that add to a certain sum. So a diamond problem, what it is the two numbers that are outside here, they multiply to give you the top number, and they add to give you the bottom number of the diamond, and we're going to use it for factoring. So doing these diamond puzzles just helps you kind of practice for when we're going to use it for factoring. So like 10 times 7 multiplies to 70 and adds to 17. Kind of hard to see. So if you add, you multiply to get the top and then add to get the bottom. So if I skip down to like number 10, for example, now I've got what they have to add up to on the bottom, 15. So this cell over here to the left would have to be what? 3, because 3 plus 12 is 15, and 3 times 12 is 36. So when you start factoring, you'll have actually the top and the bottom of this diamond puzzle. Let's do one that's negative. So let's skip down to number 15. Negative 96 is the product. So negative 12 times what will give you negative 96? I don't know, is that 8 or 9? You guys are confident with your 12 times tables, huh? Very good. So it would have to be positive 8, right? So positive 8 times negative 12 is negative 96, and positive 8 minus 12 is negative 4. Do the diamond puzzles sound familiar to any of you? Okay, some of you have never seen this, some of you have seen it. So I'd like you to kind of, all right. So the hope is that if you do the diamond puzzle enough, it's like second nature on how to do the diamond puzzle, so that when you use the diamond in factoring, it helps you. These are a little bit harder, like when you've got the two terms on the side, you've got to figure out what adds to that number and then still multiply them together. So the bottom one seemed a little bit harder. The two numbers that you're going to have are the top and the bottom, and you're going to have to figure out the two factors on the side. So having mental math skills to know the factors of 36 are going to help you, because like you'll have 36 and 13 and you'll have to figure out this 9 and 4. So I found that students that kind of struggle with some of their mental math skills, it makes factoring harder because you don't know the factors. So it's a good time to brush up on your mental math skills. So here's how you're going to use that diamond to help you. So you're only going to use this strategy when you've got a quadratic that's a trinomial, 3 terms, and the leading coefficient is 1. So there's another strategy for when this is no longer a 1 here. So we're going to draw our two sets of parentheses, put in our variable, do the diamond puzzle, and solve it. So basically, when you get down here, you're looking for two sets of binomials, and you know that it has to be x times x to get x squared. So you can immediately write your two parentheses and put an x in each. And then you're going to set up your diamond puzzle. So the diamond puzzle really comes from the a value times the c value up at the top. So this is a times c, and your b value is actually on the bottom. So when I set up my diamond, it's really negative 12 on the top and positive 1 at the bottom of the diamond. So you're looking for the factors of negative 12 that add up to positive 1. So what are the factors of negative 12 that add up to 1? So you could use like 12 times 1, 6 times 2, 3 times 4. One of them has to be negative. So it would have to be positive 4, right, times negative 3, because you have to add up to positive 1 at the end. So 4 and negative 3 are the solutions that go in your parentheses over here. X plus 4 times x minus 3 would FOIL back out to what you started with, so it's the factored form. And it says check your work by distributing with FOIL, right? X times x is x squared. I've got 4x minus 3x. Yep, that's 1x. And then 4 times negative 3 is negative 12. See, I like factoring personally because I can always check that I have the right answer. Don't you like that about math? You know that you have the right answer, right? It has to go backwards and make sense. So on part B, 1 is going to be your multiplier and negative 2 has to be the sum. And you're looking for the two factors that multiply to positive 1. So we know that has to be a 1 and a 1, right? But I need negative 1 times negative 1 to get positive 1. Negative 1 plus negative 1 is negative 2. So I should have set up my factors, put an x in each, and they both are x minus 1 times x minus 1. And I wrote a note at the bottom of this page that says note B and D are called perfect square trinomials. So I could also write my answer x minus 1 squared, and it means the same thing. You don't have to do that step right now, but when you do completing the square, there's a reason we need a perfect square trinomial. So there's a big difference between just two binomials and the same binomial twice. So there's a difference between these two problems, but we factored them with the same strategy. All right, so I'm going to keep doing a couple more examples with you, and then I'm going to show you the other strategy on the next page. I've got a bunch of practice when we get to guided practice. So, all right, so C, when I set this one up, I do x times x, and then I'm looking for the factors of 32 that add up to 12. So can someone help me out? What are the factors of 32 that would add up to 12? Yep, 8 times 4. So 8 and 4. It doesn't matter the order that you put them in. If you put 4 and then 8, because what's the whole purpose? We're trying to solve this one. See how it says equals 0? So at the end, I'm looking for what my two solutions would have to be. So my two solutions are either negative 8 or negative 4 for this example. So make sure that when it says factor and solve, that you actually solve. So why don't you try D? Try, if you haven't yet, try D, and I'll put the answer up in just a minute. But we're going to build on this strategy for a little bit more challenging trinomials. And you should have put 16 up top, negative 8 on the bottom, so it would be negative 4 times negative 4, right? X minus 4 squared. So if you want to write it out, just make sure where you're putting that squared symbol. So another perfect square trinomial, it only produces one x-intercept because it's basically bouncing off the x-axis, right? Its vertex is at right 4. So just knowing that there are things called perfect square trinomials. So I'm going to show you the last strategy so that when we come in, we can do some practice together, because this is a harder strategy. If you've never factored before, this definitely takes a little bit more perseverance. So the only difference this time, you still have a quadratic, you still have 3 terms, but this time the leading coefficient isn't just 1, like x squared. It's going to be 3x squared or 10x squared. So it makes it a little bit harder because you can't just do the first step of putting an x in each box like we did on this page. If I start and I've got 7x squared, I've got to have a 7x and I've got to have an x. Or if it's not a prime number and I have like 8x squared, I'm going to have like 8x times x or 4x times 2x. So it makes doing it in your head a little bit more challenging. So we're going to do the diamond, but then once we get our answers to the diamond, I'll show you 2 different strategies. The box strategy, if you get it, I would just keep with the box strategy. There's another strategy called grouping, so I can show you that strategy too in case you've seen it in middle school. Huh? I don't know which way. See, people teach factoring. There's a bunch of different ways. All right, so we know that we're shooting for these 2 binomials, but we can't just write x and x. So that's what our final answer is going to look like. but it takes a little bit to get there. So your first step is to still do the diamond the same way you've been doing the diamond, except A times C, you don't want to forget to multiply by A. So 7 times 4 is 28, and 29 goes on the bottom of the box. So I think you can see what your factors are going to be. 28 times 1, right? So wouldn't it be nice if it was just x plus 28, x plus 1? But 28 times 1 is not 4, right? And x times x is not 7x squared. So there's another step that you have to do. So it's something called the box method. So basically, we're going to find our factors on the outside of this box at the end. So we're going to put these original terms in the box. 7x squared goes in the top left. The constant 4 goes in the bottom right. And we're strategically splitting up this 29x into the other two boxes. So it doesn't matter where you put 28, it's 28x, right? Because 28x plus 1x is 29x. So these four terms are representing this same exact trinomial that I started with. They're equivalent. And now you're going to find the factors on the outside of the box that would be the dimensions of the box to get those area inside the box. So I know that it has to be a 7x times a 1x. I strategically want to put 7x in this row because I'm going to have to multiply to get 28. And I'm going to strategically put x up top. So x times 7x is 7x squared. X times 1 is 1x. And 7x times 4 is 28x. And double check, but 4 times 1 is still 4. Those are your solution factors. X plus 4 times 7x plus 1, and then you should double check with FOIL that you got the right answer. 7x squared plus 29x plus 4. So see how this 28 and this 1 don't show up in the final answer? The 28 and the 1 show up inside the box. And just in case some of you like grouping, to refresh your memory, instead of setting up the box, you write out your 4 terms for grouping. Does that look familiar to anyone? So if you've done grouping before, maybe use the grouping strategy. You take out your greatest common factor. Does this look familiar? If it doesn't look familiar, why throw another strategy in your hat? But you group, pull out the greatest common factor, and then your solution is the greatest common factor and then the coefficients. So if you've learned grouping and you like grouping, stick with it. If not, I'm just going to keep calling this the box method. As long as you have one method, you're good. So example 2, I know that my final answer is going to look like this. And I'm going to set up the diamond. So 2 times -9 is -18. -3 goes in the bottom of the diamond. So what factors would I want to use? Colin, are you doing this along with us? Cooper, you are too? You don't want to miss it. Willem, are you doing this along with us? Okay. This is hard, so I don't want you to zone out. This is the hardest factoring strategy. We're doing it together. What are the factors of -18 that I'd want to use? Yep, -6 and +3, because that adds to -3. Good. So I can't just write my answer. I have to go and do my box. So I'm writing out this trinomial just using 4 terms. So 2x squared goes in the top, -9 goes in the bottom, and I'm going to use this -6 and 3 to split up this -3x. Doesn't matter where you put them. You just got to put them on the diagonal. So now you're filling in the outside of the box to get your 2 factors. So you know that it has to be a 2x times an x. When you look across the row, you'd want to put the 2x across from the 6, not across from the 3. Does that make sense? So you're kind of looking at the greatest common factor of the row. So x times 3 is 3x, and 2x times -3 is -6x. And then -3 times 3 is -9. Are you kind of with me on how to do the factors of the box? I know it's kind of abstract if you've never seen it before. X minus 3 times 2x plus 3 is the final solution. Make sure you write your final solution using factors. And if this is a 3, it means plus 3. If this is a minus 3, obviously it means minus 3. You want to do one more? Oh, I want to point out something to you on example 3 and example 4, actually. So example 3, what do you see first before you even start doing your diamond? Does anything pop out to you? Huh? The 4? Yeah. The first strategy for factoring is to look for a greatest common factor. Is there a greatest common factor in this problem? Yes, there's a 2. So, what? Oh, that's why you said 4. Okay, so if you can take out a greatest common factor, I recommend that you do. It'll make the rest of the problem usually easier, and you'd have to take it out to get full credit anyway. So I really have 2x squared plus 11x plus 5. It'll just allow you to work with a smaller set of factors or numbers. So my final answer, I'm going to have that 2 out front, and then I'm going to have my 2 binomials. So make sure you don't lose your greatest common factor. That's part of your answer. But when you do your diamond, you only do the diamond with the trinomial. So 2 times 5 is 10, and they have to add up to 11. So what would be my factors of 10? 10 and 1. So inside my box, I'm trying this trinomial, right? So 2x squared and a 5, 10x and 1x. So go to town. See if you can figure out what your 2 factors are that go outside that box. Take a minute and try it. 4, and then we'll pause, and when we come back in, you'll be doing them kind of on your own. The only reason I want to draw your attention to number 4 is because they haven't put them in the correct order for standard form. So before you start to factor, my first step, I like to put it in standard form first. And I do look for a greatest common factor first. And this one also has a greatest common factor, right? I could divide out a 2 this time. So this is really 2 times 6x squared plus 11x plus 3. 12 times 6 would have been 72. So you'd be looking for a lot more factors than just 6 times 3, which is 18. So it just makes the diamond a little bit easier to find the factors. So 18, 11 goes on the bottom. See if you can finish number 4. So everyone set their box up with a 9 and a 2, right? 9x, 2x. So you're working on these 2 factors. And then don't forget at the end, you need to put a 2 out front, binomial, binomial. Does that make sense, Ginger? How we did have the same answer, but you had 6x plus 2 right there. So at the end, you want to suck that greatest common factor out. But this stays the same. 2x plus 3 was one of the factors that you got. Okay, so I had 3x squared, 6x plus 2. Yeah. Yeah, so how do I know where to pull out the greatest? Well, there's no greatest common factor there. It's just a greatest common factor there. So it wouldn't matter on mine. I could write my answer also 2 times 3x plus 1 times 2x plus 3. So the 2 binomials are really like interchangeable with each other. The greatest common factor sits in the front. Okay. So someone else might have gotten 4x plus 6 times 3x plus 1, and that still would have been correct. It's going to give you the correct x-intercepts. It's just not considered factored completely if there's still a greatest common factor. That's all. Okay.